Hello and welcome to my series Learn Radiology with Dr. Anil Joshi. Today's topic is based on the ultrasound physics and the lecture series deals with a simplified form. The lecture is meant for the radiology students, radiology technicians and those doctors who are going to practice ultrasound because basic of ultrasound will help them to get a better images and to eliminate the artifacts. To start with a disclaimer. Most of the illustrations here we had taken from our department. There is certain portion or certain illustrations which are downloaded from net. We have seen that they are royalty free. We acknowledge with thanks from those from whom we have got the teaching material. Now coming back to the today's topic of ultrasound physics, that is properties of ultrasound waves. Let's consider different properties of ultrasound waves. Ultrasound waves can show following properties at tissue interaction, that is reflection, refraction, absorption and attenuation. Now we'll see each of them in detail. First is reflection. A reflection of beam is called an echo. Production and detection of these echoes form the basis of ultrasound. A reflection occurs at the boundary between two materials, provided that certain properties of the material are different. This property is known as acoustic impedance, which is a product of density and propagation speed. If two materials have the same acoustic impedance, their boundary will not produce echo. If difference in acoustic impedance is small, a weak echo will be produced, indicating most of the ultrasound will carry on through the second media. Next is a reflection. If the difference in acoustic impedance is large, strong echoes will be produced. If the difference in acoustic impedance is very large, then the ultrasound will be totally reflected. In soft tissues, the amplitude of an echo produced at a boundary is only a small percentage of the incident amplitudes. The media containing bone or air will produce large reflected echoes, resulting into not enough ultrasound waves available to image subjects beyond this interface. This helps us to identify two things. A bone and air can be diagnosed looking at this character number 1, and number 2, we know whatever is beyond them is not going to be projected. Since there are no ultrasound waves which are propagating through into the next media, once there is a bone, once there is air, you will not find any additional tissues being imaged beyond them. Now, next property is refraction. Change in the direction of a sound wave on being incident upon a tissue interface at an oblique angle is called as refraction. You can see in a diagram the incident ray or incident ultrasound wave, how it is coming and it is getting deflected. That will give you an angle of refraction. Now, it is governed by Snell's law. For those who are interested, can pause here and get a better idea of what is a Snell's law. Next is attenuation. Deeper the sound wave travel in the body, the weaker it will become due to loss of energy or due to decrease in amplitude of the wave. Sound is attenuated by body tissues. It is a result of three processes. Attenuation is a result of three processes. One is reflection, absorption and refraction. More tissues to penetrate will result in more attenuation of the signals, and this reduction can be compensated by adjusting gain. Now, ultrasound operator, what he gets, if he finds that not enough echoes are coming back, he increases the gain. There is another way also. You select a proper probe for that depth. Different probe has got different frequency probes and there are different gains. This setting can give you a proper imaging after knowing this property of a ultrasound wave. Then is the acoustic impedance. If two materials have same acoustic impedance, no echoes will be produced. If there are two different materials, there will be a interface. A reflection will occur at the interface of such two materials which will depend on the property of the material, that is acoustic impedance. Now we'll come to the scattering. What is scattering? Not all the echoes are reflected back to the probe. Some of them are scattered in all the directions in a non-uniform manner. This is especially true for small objects. If the objects are very small, then this will occur, or through a rough surfaces. The part of the scattering that goes back is called as a backscatter, and that reaches the transducer to generate an image. Then we'll come to the absorption. Tissue absorption of sound energy contribute most of the attenuation of an ultrasound wave in the tissues. With this, we are ending our brief lecture on properties of ultrasound. Those who are interested can go to our website or on YouTube channel to get a detailed lecture on this. I thank you for giving me your valuable time. Do spend some time on the physics so that you can get better images, better analysis, and better diagnosis. I thank you again. Thank you. Goodbye and take care.